Now the real fun begins, figuring out tools, tool paths, strategies, angles of approach, all that other good stuff. And let's get started. Hey guys, it's that time again. I don't know how many hours we got into this together so far, but if you're still with me, man, I appreciate it. You're a real champ for sure. So, where we left this off the last time was we put some tabs on our model that will allow us to machine 98% plus of this model, and second operations will only be removing the tabs or what's left of the tabs when we are done with the first operation on the new machine equipment. So this is where this sits now. We're going to start let's do a new file here, and let's call this overhead motor housing op 1. Okay, and we're going to save it in this folder we're in now. So, all right, we got a new file, and we're recording our history. So let's insert a fixture in here. I'm not going to put the whole machine table and the rotary and everything because that is takes up a lot of memory and space, and I know I'm not going to collide with my table and other items. So let's see here. Let's rotate that 90 there, and all right, we're going to call that good. Let's see. And let's ground that. So that now has a permanent home. And let's see. We're not going to alter it anyways, but let's just break the link from the original. And let's see, where were we? This is our motor housing, so let's insert this. Bring this way up high here, and let's see, where's the... I believe we've got to rotate that 90 degrees, and I think that's good. Let's turn on the stock, and we need to rotate that, so let's make a rigid group of these so those two move together, and let's flip that 180 degrees. Okay, so, oh, I've got to move it one more time. I didn't bring it in a proper orientation, so not a big deal. We will just move that 180 degrees, and now you can see you've got the dovetail clamp face down here. You've got this indicating pin feature there, and that will sit right into that pocket. So repeatability is pretty important here. So we already have a origin point on there. Let's create a joint origin on this surface here. And let's bring that up to that face. Okay, and always grab the item you want to move first, even though the first one's grounded, so it wouldn't let me anyways. But let's install, create this joint here. Now, there we go. Our part and stock is located perfectly in the dovetail of the vise, which is a pretty big deal. Excuse me, I'm a little parched here. So, all right, winter dries everything out. Okay, so this is the basic layout here. So realistically, let's just save it. We save all the time. Let's just give you a quick idea here of we're going to do a circular pattern with components, and we're going to select this component. We're going to select this axis, and we're going to say 4 pieces. Okay, so this is just for giggles. I'm not going to do this way right now, but basically now you can see how it will hold 4 parts and essentially allow me to do all 4 parts at once. As long as when the tools are coming down to machine this part, the tool holders are not going to collide with theirs. So there's where you're going. That's the one thing I have to take into consideration. I could possibly bring the bodies a little closer to the vise, lower them a little bit, but I got to make sure I have enough clearance around here to get in a tool and have decent pathways for the tool to enter and exit and not collide with my vise, my clamps, and things like that, because I will tell you those parts are very expensive. So I am going to right now just get rid of the rest of those features because I don't want to get myself confused as to which one I'm playing with and which one I'm not. Once I have all of the CAM programs completed, it's much easier to just repeat that in 4 locations. So let's just tinker here with some basics. Let's turn on, I'll say this sketch. Nope. 527. There's 27, I think, is the one. And what that sketch does is it's a little bit above my vise and my clamp here, but it's at least 10 millimeters or 3/8 of an inch away from the top of the motor housing. I also have at least 10 inches, not 10 inches, 10 millimeters, 3/8 of an inch extended around the full perimeter of the part, and basically that's going to be what's called a containment area. I'm going to contain my cutting tools within that area, so my cutters should not come south of this and go into my clamps. You test and prototype everything anyways, but run test programs, dry runs, and things like that. But I just need that for some of the features. So let's just get into another part of the program. Let's go to manufacture. First thing we do in manufacture is we need to create a setup. Now, there's all different places to indicate on the machine tools. Basically, what I'm going to utilize is this hole on the end here. Don't know why. I may change my mind. I may want to use the center of the round platen face as a 0 origin for everything I machine off of it. And where that means I need to sort of model that in this setup for accuracy. Everything I do on the rotary axis is always uses the same zero origin point, I will run into a lot less problems down the road. And I can always change that. That's not hard. I could do all this modeling. I can do all this code. I can get it all done. And at the very end, I can bring in the round face of the platter, put it on the back of there, and then create that as my 0 point, and it will go back. I will hit regenerate. It'll regenerate all my code based on the new origin point. So it's not super important right now, but I'm gonna do this anyway. So we're gonna select our pause VF2SS machine. We're doing milling operations. Let's just pick the Z face. I'm going to grab the front face of this feature. I'm going to put my x-axis at, well, let me do that circle. No, it will not. All right, so this is an x-axis line here on the feature. Come on. Let's delete that x. Oh, I'm sorry, I grabbed the wrong face. This one's facing upward, so that's going to be my Z face. That's my X face. And let's use a selected point of, it's automatically going to grab the center of that circle. So that is considered my zero origin point for my machining. So I'm going to flip my X because it's got to go the other direction. Come on, there we go. So that's my 0 point. Anything to the right of that is X positive. Anything going away from me is Y positive. Anything going up is Z positive. Um, okay, so we've got that. Stock, let's go with a solid, and we're going to pick the stock that we created earlier. Let's just give this a generic 501 overhead motor housing one. G54 code, we'll do that for now. I may change that later. I may designate one single permanent work coordinate system for the rotary, like I was talking about earlier, on the center of the round platen. But for now, this is good. Everything else, if I go back and change it, just takes a couple of keystrokes. No model selected. Okay, model is, let's turn off. Come on. Let's just select that body. Well, let me select the body. No, why are you not? Oh, there we go. No, that's not what I want. There we go. Okay. I swear sometimes you have to click things twice, but such is life. Okay, so now we have our setup. Everything's based off of that 0 point for any machining procedures we do from here on out. So let's just, first thing we want to do is remove a significant amount of material. So let's do an adaptive clearing process. I'm going to, I've got a tool list just opened on my other monitor just so you guys can see. I work on dual monitors to make my life a little bit easier. Okay, so I'm going to grab a 3/8 inch roughing and mill. Let's see. Oh, wrong. All right, so There's a standard 3/8" roughing end mill I normally use. Tool 7 in my tool crib. And most of the basic settings on that should be fine. I'll fine tune those later as I'm actually cutting material. I may increase speeds, feeds, whatever has to happen. Machining boundary, we're going to select that. And we are going to rest machine from the previous setup. Tool orientation, this is an important one. We're just going to pick a face that we want to call Z here. And I can grab any face. It doesn't need to be in the model. Just anything that's pointing in that direction. So, but I will turn on my stock and I will grab that face. I'll turn off that sketch. All right. Oh, again, this trying to teach and do things at the same time is a real pain in the butt. Okay, so then x-axis is any exit line is completely fine. Z height, so I'm just going to rotate my model. I don't need to cut all the way down. Those heights are perfectly fine there. What I want to do is drag my Z bottom up. That's about the center point right there. I'm going to go, if this is the top, then this is the bottom. I'm going to go a little bit below half. Okay. And now you're seeing the program starts to, I like to just set the basic parameters and then just see what the computer wants to give me right from the beginning. And that is a pretty cool looking toolpath. Okay, so let's do kind of the same thing from the back side. And I will just duplicate this toolpath. I will go in and modify it. All I really need to modify here is I want to use the same machine boundary. I got to turn my sketch back on for that. And I basically just need to change my tool orientation to the back side of the project. And then I don't need to grab that other X would have been fine, but I just want to do that anyways. Okay, and then Z, let's look at the, okay, so that actually did it. Got a little bit below, maybe don't need to go that far, 0.4, oops. Four, no, wrong way, 6, there we go. I just want to go just past the center line a little bit. And click OK, and that's going to generate toolpaths in that direction now. Okay, and let's just highlight the setup. We'll go into simulation, and you can kind of get a feel for what goes on in here. Okay, it's going a little fast, so I don't want it to go too fast, but I also don't want it to go too slow. So this simulates the tool's actual cutting paths, what it would be doing. There would be a red bar indicated somewhere down here if the software found itself colliding. Any part of the tool holder colliding with my fixture, it would alert me to that. And then you go in and you make adjustments from there. Okay. Now I'm going to modify this even more because I don't want to remove all of this material. I want to leave this heavily attached to the vise until near the end. But I just wanted to give you guys a quick image as to how this plays out shortly, the tabbing feature. So yeah, it would leave just these little pieces. And now this leaves a lot of excess material because with the roughing tool, you're leaving material. So it's leaving material on the sides, it's leaving material at the bottom. So these tabs will not be anywhere near this thick. And for the most part, to be honest with you, what I may do is handle this completely different. I may come in and drill the hole down through the body first, cut the taper, cut the threads, all that down to a certain level, and then I will probably come in and while it's still a full block, I will come in and bore the RCA feature cavity and rotate the other way, and then the small cavity where the needle bar or pusher bar goes down through the base of the housing. I will do those three things because that's removing, that requires a fair amount of machining force. So I want to do that while I have the most stock in the attached to the vise for a more secure hold. So I'll probably do those operations prior to this roughing operation, which is not a big deal for me to go and do that. So let's quickly we'll do the drilling operation first. So we'll do a drill, and the tool we're going to want to use is going to be, let's see, through the spindle coolant drill. What diameter? Probably, let's go with 9/32. It's a little over a quarter of an inch. And what I want to do is hide my stock, go in here, hole faces. I'm really just going to grab any round surface that's concentric with where I want to drill the hole. I don't need to pick the specific hole because this doesn't even stay a perfectly round hole. We modify it from the other side. So now we've got the center of the hole picked, and we're going to just simply adjust the hole bottom. I'm going to make that from a selection. I'm going to just grab a random point here, and then I'm going to drag that down a little bit, looking at it from the face. So basically, all I really care about is that the drill is going to come at least down past where I need it to. I don't have to worry about it cutting into something that is, it shouldn't, the way we've laid it all out. So that's that. Okay, so let's see, let's turn off that sketch. And because we want that drilling operation to go first, we just drag it up to the top. And then let's do the rough cut adaptive again. It's already picked the 3/8 roughing tool here, which is the last non-drill tool we use. So let's go in and set up our tool orientation. And we're going to pick, this time we're going to pick this face here for our orientation. And again, it's asking me for an X reference. Any X on the fixture is totally fine. Let's go to our Z heights as far down as we want to machine. I'm going to machine down to, actually, let's do let's do a selection. Let's pick this edge, and then, to be honest, I'm going to pull it down. Oop. All right, so then I'm going to pull that down just a little bit to make sure I'm getting everything done that I want. And I didn't do a containment, so oh, this is external, that's why. Okay, so let's go back to our Z heights and look at it from the straight here. All I want to do is make sure I get down to, let's add 0.1. Oop, I didn't mean to do that. There we go. We don't want to be, we want to make sure we're not really sort of cutting into any of the body contours because this is the outside. So, okay, let's do that. And again, let's drag that up to the top. And now we're going to, let's see, let's do a contour on the inside here. Let's do that with, oh, let's stick with the adaptive clearing, why not? And this time we're going to get a different tool. We're going to need a smaller tool to get into that cavity. So let's look at, all right, here we got a 1/4 inch longer flute end mill, and we want to do this time the interior features here. So we're going to grab a selection for our bounding box, being this circle. We want the tool to stay inside that bounding box, and we're going to change our tool orientation to dictate what angle we want the machine at. There's our Z. Zoom out and grab an X line. There we go. Z height. We gotta play with this a little bit because we certainly don't want to go that deep. Let's go down to we'll allow it to go down into the body. I don't think it will, just due to other constraints. Okay, so maximum roughing step down, we only want, say, 0.125. Let's go with 1/8 of an inch there. And let's see, ramp clearance helix. Let's go with a 0.5. And let's see what it gives us. All right, we got a warning. It's always fun. And it doesn't give me a real warning. It just tells me something's wrong. Those are the fun ones. Okay, so what did I do here? Z-axis is that face, edges there. Tool orientation's fine. Let's see. No additional offset. I can give that a little bit of 0.1. I won't allow it to go too far over. Let's do previous. Always do from previous. Our heights are fine. Our passes is fine. Step down. Let's go 0.0625. What am I missing? Oh, that's what we're doing. We've got way too much stock to leave there. 0.005 is perfectly fine. We don't need to leave any on the axial, just the radial. So, and now let's press go and see if it generates. I was asking it to do something it physically couldn't do. All right, so now you can kind of see what it would do down in there. And let's you can see it's a little wider up here, it narrows down. Let's see what that looks like. Let's bring that up to the top. Let's regenerate that because we put them out of order. And all right, so now we have our drill. We have our adaptive for our taper. We're going to remove material around the outside. Let's turn our body back on. Let's grab our setup and simulate. We haven't saved in a while, so let's do control save. There we go. All right, now we'll grab our setup and see what it shows us. Okay, so there's the drill. You saw the tool turn red there, the big red bar down here in the beginning. I impacted something. I'll figure that out. But you can kind of see where it cut the cylinder, cut it oversized. We'll do a finish cut and then we'll do a threading on that. But for the most part, we can get a good idea as to whether we're headed down the right path. And again, once you even get all the basics in there, get back and you fine tune and you refine tune, and then when you actually start cutting metal, little things will show up along the way as to what needs to be adjusted or done and all that other fun stuff. So, but you can see, you get the basic idea on kind of how this goes. And if you look, this is a rough cutting, so you get all the little stair steps. But what I want to, the object of that is to get the basic rough shape, remove all the material, and then let a much more precise tool come in. And that tool doesn't need to work as hard to just take out the little bits of material left. So this does not look as if it's tapered. So, and I think I know why. So which one is that? That's this. Okay, so let's go in here. Stock contours. We did not do the stock contour. All right. Let's see if that's going to give me the results I was kind of hoping for. No. I'm missing something. And it's kind of weird because I did it successfully last night with a different model orientation before I decided to go with the tabs. So that's going to kind of bug me. But not a big deal because there's all kinds of buttons to push and play with. So let me see, what am I missing here? Let's go back to 0. Let's turn off stock contours. And then we'll go. We'll see what it generates now. There we go. Now I'll turn off the body. And you can see that it's going to step down and cut a narrower circle each time down. So it'll be like an inverted cone. Okay, so sometimes you just forget how to do things. So let's see here. All right, setup, simulate, go. We don't need to see the whole thing to just to see how that works. Okay, so then the next well, let's just do everything we can from this orientation to start with here. So, okay, so next thing we want to do is we want to take, after this adaptive, we want to, one thing we didn't do in the very beginning was a facing operation. So let's do the facing operation with, let's grab a simple 1-inch tool in the very beginning, and let's grab that and just press go. All right, so the very first operation comes in and it cleans the face of the part off. And so I drag that to the very first operation, then the drill, then the adaptive, which we're just regenerating with the Control G for generate. And then the next operation we would want to do, we would do a contour. And I need to look for my tapered end mill. Bear with me, I'm digging through my tools here. It's not there. Okay, so this is my 7-degree tool. You can see the taper right on the end there. And what I'm going to do here is get in here, select the contour. I don't like the angle and the lighting I get here. All right, this is the contour we want. And just simply press go. And that will make that nice smooth conical taper that we need. And again, I'm going to go back. I'm going to fine tune this a little bit, but this is realistically the bulk of the rough work. One other thing I do want to do while I'm in here, I'm going to drag that up to after the adaptive. And the best thing to do is to face these, like face drill. I don't need to rename those, but this is, so adaptive 3 underscore tapered hole. The more notes you throw in, the better off you'll be. Contour underscore taper, and all right, so after that one, I want to do a contour because I do want to clean up the bottom of this here without any excess material here, because I want the collet to fit in there properly. So we're going to grab another contour move here. We're going to go back to that 1/4-inch tool that we used, and that's the contour we want to get. Tool orientation, which I didn't add that to a couple of those. I got to go back because it would probably execute just fine, but at the same time, even though I'm working in with the A-axis in the 0 position, I could get away with this top work without it, but it's just not worth the chance, to be honest with you. So tool orientation Z, I'm going to work on that face, and the x-axis, we're just going to grab one of these X lines again. Down to the selected contours and go. So all that's going to do is go down and machine that bottom flat exactly where we want it. So that's also going to get dragged up to you know what, we'll do that before the taper. So, because that we have the same tool in order. So you want to minimize your tool changes too. Okay, so let's just quickly, at the same time, let's do one more contour of the outside of these threads. And we want to, oops, that's not one. On that face. Okay, so we want that face, and come on, Mark. Well, we've got that 1/4" tool. We want to select, you know, let me select that face. No, you're going to want a line. All right, I would need to generate a sketch on that. But there's also another way we can do this, and that is to can do the adaptive clearing with, normally I just go back and draw a sketch with the diameter that I want, or actually realistically I already know it, there's a sketch already in there. I would go back and find the original sketch for those. That way there, if I went back and changed the diameter at any point in time, parametrically that would get pushed forward, but it doesn't need to be that complicated. So okay, so let's grab that 1/4" tool and physically do a tool orientation, Z face there, X face here, and I'm not worried about the machine boundaries. We are going to go with a selection, bottom edge there, and what we do want to do is consider the previous work that had been done, and that should allow us to 0.25. This is our max step down on that, so that should allow us to not cut a lot of air. Okay, so whatever, it does a lot of dancing. This is where contour comes in so much better. So I will go back and do it the old-fashioned way. So let's just kill that idea. We are going to open up our sketch dialog. This is why we went back and named a lot of these things. And you can see towards the end, I got off the path, but I will eventually, once I finalize all this, spend hours and hours and hours going back and buttoning up loose ends. But all I really kind of need to do here is look for this surface, and it generally is going to, oh, boo, loft top, loft two bore cut, cover about, leave sketch. Just start turning them on and off. Oh, none of them are visible. So, all right, so we're going to look for Would have been prior to that, so relief cuts inside, sketch, housing face, flatten back, lower cone. Two bore cut. Isn't this fun? Off to bottom. All right. No patience for that right now. So what we're going to do quickly is we'll go back into design and look in here, and what we will, oh, I brought the product over. That's what that is. So let's go back to our original absolute original work that we were doing. Um, and in motor housing, turn this angle all the way back to, hey, look, not that surface, this surface. Now, motor housing, where is this? Let's get on that, and where did that surface come from? Okay, so it was this extrude, so there's a strong chance. There it is. And what sketch is that? That is sketch number, not saying. Sketch number 6. Where is 6? I don't even see 6. 6. All right, so sketch number 6. All right, now let's go back into, I know, boring watching all that, but so let's close this, get back in manufacturing. There's a lot of back and forth. So what we're going to do here is we're going to pick a contour. We are going to grab that 1/4" finish tool that we had, and we are going to do the tool orientation. We don't want to forget that. And pick our Z face, pick an X line, and let's contour selection is we want to pick, okay, first tools, there it is. Number 6. See, there's number 6. Okay, so let's turn 6 on. Let's kill this. All we want is this outer perimeter here. Wow, that was a lot of work. Okay, and then our depths, we want to not go from our selected contour. We want to pick a selection, and I want to pick, this is my depth, because I want to go deep enough to cut it, but I don't want to get in any of the body. And this one here, I'm actually going to go with stock to leave. I'm going to leave 4 thousandths, and that just leaves it slightly oversized so that the, oh, it's actually cutting the inside of that line. So that's not a big deal. We go back in here. All we do is click this red arrow, and now we're going to be cutting outside of the line, which is kind of the key. So, all right. And then that was the 1/4" tool. So let's do the up in this range. Okay, so, and I forgot what thread we used on that. So let's just quickly grab the thread, slide up to wherever it is. This is the thread. Let's see what we used. We used a M18 by 2. Okay, so I just got to kind of remember that. M18 by 2. So then I do not have. Oh, I need to order those. I need to order some threading mills. So I don't have one. I don't have the tool in my inventory. I don't have it built in the CAD, so I can't quite do that right now. So let's see, we're going to turn off Sketch 6 now that we no longer need it. Let's hit Control Save. We haven't done that in a while. Let's go to Setups, Simulate, and other than the threads being cut in, you have a real good idea as to kind of how this goes. See, it just faced the surface it needed. It didn't remove the, oh, okay. I've got to swap some good stuff there. Need to remove that. Need to remove that large volume of material first. So this probably should go right after the face. And that just needs to be regenerated. And sequence, a lot of different sequences. Okay, so there we go. Removing the bulk of the material, going down. And just pause this here. But you can kind of see now that the taper's cut properly. The tube rest here to keep the tube from going up and getting too far into the motor cavity where it can create problems. That rest is machined. The tool taper is done, but I'm getting a radius down here for the tip of the tool, so I'll need to offset that a little bit. Not a big deal, but you can kind of see left a little bit of a material removal here. Basically, that chamfer will be cut, and then the threads will be cut externally, and then essentially this end of the machine is done. And as we move on into the next future machining steps, the computer's smart enough to recognize material's already been removed and not try and remove it a second time, as long as I use the rest machining process. So I hope this was a little bit interesting anyways, and yeah, we're getting closer to a final tattoo machine design. CAM manufacturing produced. I still got to put the proper fixtures on the machine downstairs and get those dialed in. That won't take long at all, maybe a couple hours to get them dialed into within a couple tenths of a thousandths of an inch, and nobody I know can see that with the naked eye. So absolutely cool. I'm enjoying it. And thanks for watching, man. Hit that subscribe button, smash that like button, as they say, and share these videos with your friends if you like what I'm doing. And don't forget to comment below, man. I love interacting with you guys. I'd like to hear your ideas, suggestions. By the time this airs, it's going to be too late for this, but I might start dialogue on the next machine, the next big thing, or maybe a version 2 of this down the road as we find out what maybe could be better. Who knows? So anyways, thanks for watching. Well, we got some rough strategies done, and if you're a real machinist out there and you're watching this, I'm sure you were probably screaming at me through the monitor saying, Oh my God, your x-axis is pointing the wrong way. Oh my God, you're gonna crash that. Your tool's chewing into your vise. I know it all. Paying attention. This is just to get some rough stuff down before I go anywhere near putting power to this thing. It's going to be operation by operation, looking at the details and making sure it's all right. So just calm yourself and wait for the next one.